Very good morning, everyone. Today we are going to have a look at time division multiplexing and type of carrier systems used ubiquitously all over the world. Time division multiplexing is a digital process. It allows us several connections to share the high bandwidth of a line. In this, instead of sharing a portion of the bandwidth, as in frequency division multiplexing, only time is shared. What we do is we divide up one communication time slot into smaller time slots, and there are various modes or methods for doing that. This is a typical time division multiplexing scenario where there is a multiplexer and several senders. The data flows sequentially, and at the demultiplexer, the receivers are there to receive them sequentially. This is a system where a single path and a single carrier frequency is used. It is entirely digital. Each user is assigned a unique time slot for their operation. As you can see in this diagram, the data flow is accomplished using time slots where each sender is assigned a particular time slot only. A central switch or multiplexer goes from one user to next in a specific, predictable sequence and time. TDM systems can be applied when the data rate capacity of the transmission medium is greater than the data rate required by the sending and receiving devices. It is more efficient than frequency division multiplexing in the sense that it does not require guard bands and it operates directly in digital form. There are some disadvantages also that we will enlist later on. In TDM, the transmission between the multiplexers is provided by a single high-speed digital transmission line. It can be categorized into two types: one synchronous time division multiplexing and two asynchronous time division multiplexing. In synchronous time division multiplexing, inputs are accepted in a round robin fashion. In synchronous TDM, it works by the multiplexer giving exactly the same amount of time to each device connected to it. So, this is the more apt example of such a system where there are senders with different packets. However, in a particular frame, sequentially at one given time slot, the corresponding packet is processed. So in frame 1, one from the first sender, it has A, one packet from the second sender, it has the packet B, one packet from the third sender, it has the packet C, and one packet from the fourth one, it has packet D. So A, B, C, D reading from right to left is the content of frame 1, where each division in the frame is a time slot. In frame 2, however, same process is repeated. We can see here that though the first sender has A, second sender has B, third sender doesn't have anything, and that's why this particular time slot doesn't transmit anything. However, this time slot is empty and it is transmitted in the frame as a part of the frame. So everything is fixed, time slot is fixed, and in what time slot which user or which sender will send its packet, that is also fixed. This time slice is allocated even if a device has nothing to transmit. The use of synchronous TDM does not guarantee maximum line usage and efficiency, as we can see that many time slots are empty. That means that the senders had nothing to send, the devices had nothing to transmit. There is a carrier system. T1 and ISDN telephone lines are common examples of synchronous time division multiplexing. It is used for multiplexing digitized voice stream. Another example of this we have asynchronous time division multiplexing is a method of sending information that resembles normal TDM except that time slots are allocated as needed dynamically rather than pre-assigned to specific transmitters. They are more intelligent, has better bandwidth efficiency than TDM, and they are good for low bandwidth lines. And the examples are LANs. We use asynchronous time division multiplexing in LANs. And let's have an example of it. In frame number 1, we have A1 and we have two packets of B2 and C3. In frame number 2, we have We can see here that all A's, all B's, and all C's, all D's have been transmitted in 4 frames only. So we have 3 D's, 4 A's, that makes it 7, and total of 10 packets to be transmitted. So 10 different time slots have to be utilized. We can see that in frame 1 we have transmitted first 3 for A1, B2 and C3. In frame 2 we have transmitted A1, D4 and B2. We have transmitted everything in first 10 time slots. Nothing went empty. So transmission was never stopped when the device has nothing to send. Even when the second device had nothing to send, the packet from the third device came into the frame. So we can see here that it is much more efficient than the synchronous TDM. So there are some comparisons that we can make and between the synchronous TDM and asynchronous TDM. In synchronous TDM, data flow of each input connection is divided into units. Each input occupies one output time slot, so everything is fixed. In asynchronous TDM, which in fact is also known as statistical TDM, slots are allotted dynamically. That is, input line is given slots in the output frame if and only if it has data to send. The number of slots. This is another parameter on which synchronous TDM and asynchronous TDM differ. In synchronous TDM, number of slots in each frame are equal to number of input lines. In asynchronous TDM, however, number of slots in each frame are less than the number of input lines. Third parameter is buffers. Buffering is not done in synchronous TDM. Frame is sent after a particular interval of time, whether someone has data to send or not. In asynchronous TDM, buffering is done and only those inputs are given in slots in the output frames whose buffer contains data to send. There is difference in addressing also. Slots in synchronous TDM carry data only and there is no need of addressing. Synchronization and pre-assigned relationships between input and output serve as an address. Slots in synchronous TDM contain both data and address of the destination. The synchronization mechanism is also different. Synchronization bits are used at the beginning of each frame in synchronous TDM. In asynchronous TDM, no synchronization bits are required. In terms of capacity also, there is maximum bandwidth utilization if all inputs have data to send in case of synchronous TDM. And however, in asynchronous TDM, the capacity of link is normally less than the sum of capacity of each channel. So more efficiency is with asynchronous TDM. In synchronous TDM, demultiplexer at receiving and decomposes each frame. It discards framing bits and extracts data unit in turn. This extracted data unit from frame is then passed to destination device. In asynchronous TDM, demultiplexer at receiving end decomposes each frame by checking local address of each data unit. This extracted data unit from frame is then passed to destination device. So how data is separated is another parameter where synchronous TDM and asynchronous TDM differ. Let us talk about some advantages of TDM. The first one is that the user gets full bandwidth of the channel in a particular time slot. Now we are talking about advantage of the whole TDM, whether it is synchronous or asynchronous. For bursty signals such as voice or speech, TDM gives maximum utilization of the channel. Most suitable technique for digital transmission. It does not require precise carrier matching at both ends of the link and can expand the number of users on a system at a low cost. Some disadvantages are also there. It is not much suitable for continuous signals. Initial cost is high. The noise problem for analog communication has greater effect. Extra guard times are necessary and synchronization is also necessary. So we can weigh our options whether to use TDM or FDM based upon our requirement. We will know more about it when we study about FDM in the next lecture. Thank you.